wrong, I can actually see that too. Uh, my apologies. No, something happened, and I kind of hurt my back, and it was difficult for me to drive. So um, I am. That's why we have the meeting, and things like this happen. And if it happens, we're gonna come like this online, and we're going to um, uh, try and do things online so we don't fall behind. With Workshop Zero, first of all, let's go through Workshop Zero and understand how, well, what are you involved, what are you supposed to do. Um, with Workshop Zero, I'm saying over here, submission is not open. It is actually open, so I'm going to remove that and save, and I'm going to say submissions are open. Open. Commit changes. There we go. So you got to go through Workshop Zero and do all the steps exactly as it says. If you have a Mac, you can directly jump to Mac instructions, Apple instructions, or continue with Workshop Zero. Uh, the sequence of things are installing PuTTY. PuTTY is essentially a terminal client with which you can connect to Matrix. So, for example, if I want to show you, I can actually start the PuTTY like this, and I'm going to connect as a student. So as you see, I'm connecting as a student now. And now I'm connected to Matrix. So this computer that you see, this telnet that you see over here, it's SSH communication that you see is connected to the Matrix cluster. Uh, how many of you actually seen this PuTTY connecting to thing before? Anyone? You can raise your hand so I can see you have done it. Or this is the first time. Okay, so you have seen this. Okay, all right. Um, okay, good. So the process of submitting assignments is like this. So essentially, what you do, you start doing the workshop in your repository. I think let me see if I have the OOP244 in here. Yes, this is essentially the GitHub repository that I created for this purpose. Anyway, so what I'm saying is that to submit the workshops, it's the command of submit that you're going to issue. So if I type over here professor's name, and then you put /submit, so it means you're actually submitting to FARDAT. To see what this command does, you can just hit enter now like that, and it gives you a help. So the help that it gives you, it tells you that this is how the submit is actually working. So you put the professor's name and last name and submit. You put the deliverable name, then you add submission options if you want to, or you don't put any submissions. If you put -2, it tells you what the due date of the assignment is. If you say skip spaces, that means that you did the assignment, but the spaces are not matched, and you just want to submit it like that and lose some mark, but you still want to submit. Skip lines, it means the lines are not set up properly. So if you have extra lines and you don't have time to fix it, you can use that. Feedback is to try to do you have done the workshop, but the workshop is not open for submission, and you want to try and see how it works. So for example, if I actually put this over here, so I'm going to say 244 W0, and in here I'm going to say lab section NAA. That is our section. And if I just hit enter now, it's going to say submission is not open yet. It's going to be open on Friday at 11:40. So you're essentially doing your submissions from the lab. but I want to see when is the due date, so I can simply put over here -2. That's going to tell me when is the due date. So submissions are open at this time. On-time submission is before 125. So from 11:40 to 125, you're going to do your submission. If you do it after by midnight, you're going to get 60% off the mark. After that, you cannot do any submission and you lose the whole mark for the project, for the workshop. Now, the thing is that you want to start working on it now. So if that's the case and you want to start working on it now, how do you do it? You will, for that, you need to use dash feedback. So for example, if I want to do the workshop, let me just take a look at the workshop, and let's say I have done all the steps that I wanted to do, and I want to demonstrate how I actually submit the workshop. So the very first thing I need to do is to do the workshop. So to do the workshop, I'm going to start Visual Studio. First, let me see if I have the stuff ready over here to show you. So let me actually create over here a directory. I'm going to call it demo. Okay. And I'm going to use the repository that I created. So I created a demo repository to show you. So this is the repository. OOP244 is what I asked you to create. So these are essentially the workshops that I have created. So I went through all the steps. So the very first thing I'm going to do over here, I'm going to clone it so I have it over here and I can work on it. So I'm going to right click. The very first thing I'm going to do would be click on code, click copy URL, and clone it over here. So as you see, it is cloned now. And these are what I have done before on my repository. And I have workshops over here and workshop 00. And as you see, few things are done over here. So it looks good. So what I will do over here, I'm going to make sure everything is done properly. So I'm going to open up the Visual Studio for the project that I have done. You follow the steps, it's going to be there. So this is essentially the code that I asked you to do. Just write a simple code to write something and submit it for me. So this is essentially, this is workshop 0 to be actually done inside your repository. So the code is done. Now I need to get this on Matrix. So because I have completed the project, the workshop, and I have done it on Matrix, now I want to bring it on Matrix and submit it. So what I will do over here is essentially going to my repository, do another copy. Now I'm going to go to my Matrix account. So in here, I'm going to create a directory demo2. Just to show you how it's actually done. So I'm going to say now git clone. This is only once during the semester you do this, or on any new computer. So now I'm going to clone the repository that I had, and the repository is going to get cloned over here. Now I'm going to go to OOP244, and as you see, what I had in the other one is exactly here. So I'm going to say cd workshops, and I'm going to go to workshop 0, and this is what I want to submit, w0.cpp. So I'm going to try a few things over here for you to see how it works. First of all, I'm going to name the filing correctly. I'm going to make a few mistakes for you to see what the error messages might look like when you're actually submitting. Jose, you have a question? You have your hand up. You can activate your microphone and talk.
Oh, no, sorry, I didn't notice I have my
Oh,
hand
okay.
up.
So you
I
can click
tried
on
to
it
configure.
again. You can click on it
Yeah,
again.
yeah,
It goes
I,
away. All
I,
right.
I just did it. Sorry.
Oh, no, no, don't be sorry. Actually, I hear your voice. I'm happy that you're listening to me. Okay. So I'm going to actually move this w0.cpp to another name. I'm going to call it main.cpp, something like that. Okay. And if I do that, now I don't have that w0. Now I try to submit it. So I'm going to write over here. Uh, So now I'm going to say dash feedback, because if I do this, it's going to say it's not open. I want to test it. So it's ready and I come to lab and I just submit it. So in here, I'm going to say dash feedback. And when you hit that one, it starts, as you see, it's called dry running, which means it runs it just to test to see if it's okay or not. And as soon as I press enter, it's going to stop saying W0CPP is missing. So it tells you that your file name is incorrect. So let's move it back and fix it. So I'm going to say move it back to W0.cpp. Okay, now I'm going to intentionally make some mistakes in there so you see what happens if, for example, first of all, what happens if I have uh, a compiler and at the same time I'm going to make some spelling mistakes. So I'm going to put over here student number with lowercase. So I have two problems over here. Number one, it's a syntax error. Number two is output is not the way it's supposed to be. So I'm going to exit and get out, and I'm going to run feedback again. Okay, this time, as you see, it's there and it tries to compile, but it cannot. So it says you have compilation errors. Please open errors.txt to view and correct them. So I'm going to say cat errors.txt, and as you see over here, it says in workshop 0 the function main uh, at line 10 error expected semicolon. So line 10 and fourth column, and it tells you exactly which one is it. So I'm gonna go to nano w0.cpp and line 10. I could do it. I can go back and do it on um, Windows and keep pushing and pulling. But if there are small problems, I can actually fix it. So if you look at it, this is actually line 10. So I see this is where compiler actually found the error. So right before this is where the error happened, which is here. Therefore, I'm going to add the semicolon. Now I'm going to exit again and run the feedback again. This time it says success, no errors, no warnings, and it tells you to read the following thing carefully. I am about to execute the tester and capture the output in student output.txt. Please enter the values carefully and exactly as instructed. So if you're supposed to enter any values, then you're going to do it. But this one doesn't need any values to be entered. So you just press enter to start. It runs it and it tells you checking output. Then it tells you that in line number 12 of your output, student number, and it shows what it's supposed to be, capital N. The output should be this, but your output is this. So it actually shows it's lowercase. And it's line 12 of your output, which means if you actually look at your student output at line 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Here it is. This is where you are printing something wrong, which is supposed to be capitalized. Now that's the case, you know what to fix. You're going to go back in here and say it is supposed to be student number with capital N. And you save and you get out. You run the feedback one more time. And now it says checking output, success output match, submission. This is a dry run only, nothing to will be submitted, and submission is this. So when you get this message, it means you're crystal clear, everything's fantastic, and you just need to come to the lab, open up a computer on the lab, one of the desktop computers in the lab, log in from it, and submit the code and be done. So it takes exactly 30 seconds to do it. Now, If I made any changes and I want to make sure everything is fine and dandy, then I'm gonna use that push all uh, alias that I created. So give me a second. Just a second. Just a second. Yeah. So now I want to make sure that all the changes are actually applied to the uh, repository. So I'm going to say push all, and in here I'm going to say past the uh, tests ready to submit. And you do that, so it goes through all the tests and everything and pushes all the uh, changes to the main repository. Now what I can do, I can come back to mine. So now it's up to GitHub. Now I am on my local computer at home. All I need to do is to right click over here, go toward Git and pull, or you can click on sync, git sync, and on git sync you can say pull, and as soon as you do pull, it brings everything in. Now if you look at your directory, you will see your correct output is there, the diff is there, the errors you had is there, the output is there, everything that you have done over there is now updated, and everything's fine and dandy. So this is essentially the process of submitting your code for every single assignment that you have. Obviously the whole process and how it's supposed to be done, it's mentioned in detail in workshop 0, and that's why it's essential for you to go through every single step of this one, read it carefully, watch the tutorial videos, apply it to your computer so you are ready for your semester in OOP244. Are we all okay with this? Yes, Alan.
Yeah, will be the same process for the non-users purpose?
So for Mac users, it's the same thing. Sadly, I don't have a Mac computer to show you now, but Mac is essentially like this. So the terminal that you open is exactly this. How to actually do the stuff for Mac and set up the stuff for Mac, you go to Mac instructions. So what you do, because you already have your terminal, you know your terminal, right, on Mac. And keep your microphone on so we can continue talking. Okay, you know the Mac terminal, right?
Yeah, yeah, yeah. No,
Okay,
no, what I'm talking about is the push and
it's
pull.
in your apps. If it's in your apps, go to your apps and search for terminal. It comes up and it opens a terminal similar to this one. In here, instead of actually writing how to I want to get connect, you have to obviously connect to Global Protect. I'm sure in semester 1 you already connected that one. You connect to Global Protect if you are not at Seneca. If you are at Seneca, you don't need to, but if you're outside, you do it. But instead of actually opening a terminal client, you type over there SSH, then you write your user ID, say I want to connect to, I don't know, dem,
No, yeah, yes, Professor, with when we push and pull, it will be different from the Windows directories and the Mac directory.
so that's the thing. You don't have Windows anymore. You have
Okay.
Mac. So what happens is that if you SSH to if you just open the terminal on your Mac, it means all the commands you're issuing is on your Mac.
Mm-hmm.
When you do an SSH to Matrix, then all the push and pulls that you're doing is on Matrix. Lucky for you, the process is identical in both. If you go through all the steps that you have in here, if you go through the steps that you have in here, git clone, git push, git pull, and push all things that I ask you to create the modifications to make and things that you create, they are all same in both environments because they are both Linux. So
Okay.
the process is essentially this: when you start working, step number one is pull. So you go to your if you are working on your computer at home, so what you do first, you open up your repository and you do a pull. Then you go to Xcode and start working on your assignment or whatever it is. And when you are at a certain point that you want to be done, you simply do a push all. When you do a push all, it commits and do all the stuff. And then you go do your work and come back, you pull again, you continue working. Then you do push all until everything is done. When you do the push all and you say ready to submit, then you go on matrix, you do a pull. Everything that you have sent to GitHub is now on your matrix account. And then you start doing the work over there and you submit. Does that make sense?
Okay. Thank
All
you,
right,
Professor.
no problem. So essentially, what you do is this. What we do essentially is this. Let me just try. Oh, I put the wrong one. This is the one. Yeah. So let me just draw it for you over here for everybody to understand. So what we do on Matrix is essentially this, as I'm going to show you now. So how we deal with GitHub and everything. So first of all, you create a GitHub account. By creating a GitHub account, essentially you create a master repository. We call that one. We call this one like it's usually called in computer analogy. They call it upstream. Let me just make it a little bigger. They call this one upstream. This essentially means master repository. Master repository. Then you have a local computer at home. In your local computer, you clone only first time. So by only the very first time that you do a clone. So first process that happens is cloning. So essentially what you do clone. Okay. When you do your cloning, let me see if I can actually make this a bit more. I want to have a white screen so you can see what I'm doing. That's why I don't want to draw anything, just doing this. So yeah, there we go. So you do one cloning, and this is your home computer, whatever it is. So this is essentially your home computer, or I'm going to call it my computer, whatever it is. You do one cloning, and then you keep working on your local computer, whatever you are doing. And at any moment that you feel something is happening, you do a push all. So let me actually change that thing. You do a push all. And you keep, so you do that. So everything goes into master repository. Now, tomorrow you come back because you don't know if I did something over here or not. So the next day you come back, you want to start working. So this is step one, the first time that you actually work. Now you want to start working again. Before you start working, you do another pull. You do a pull to make sure that everything that you have is actually updated. And as soon as, so you keep going back and forth on upstream and your computer, and keep working and working and working. And after you're all set and done, you do a final push all, then you go on your matrix account. So now you're on matrix. So this clone happens only once. I have to mention this. Clone happens only once. You don't do it several times. So push and pull is done over and over throughout the development. And this one is going to be a pull. So this happens several times back and forth until you do a push all and you're ready to actually get everything. Again, you only once you do a git clone, only once. And now that you cloned, you have everything in here. You try and submit it. If everything's successful, good for you. If not, then the next time that you're going to do is a pull. Remember, pull essentially means um, download. So you do a pull. If there is any uh, changes in here, you did any fixing or anything like that, then obviously you're going to have to do a push all. So in this process that you see, in this diagram that you see, your matrix account and your home computer account are simply pushing and pulling and updating the master repository. Because of this fact, it doesn't matter where you are doing this. If you forget your computer someplace, you simply go to any computer. You can pull the repository from the upstream. Obviously, you don't have an SSH key. You have to enter your user ID and password, but it doesn't matter. It's once. You do your work and you do another push and pull to the upstream, and you can do your work anywhere. Then when you come back home, all you need to do is a pull. By doing a pull, it just brings all the small changes to your computer or matrix account, and therefore there is no need, absolutely no need, to ever you put something from your computer to matrix. Your computer and matrix have absolutely no relationship with each other. You do not ever, you never need to do any type of relationship between your computer and matrix. Your computer keeps the master repository updated. Your matrix receives the information from master repository and does updates as if needed. And that's that. Are we okay with this? Do we understand this?
Great, teacher.
All right. So that's that. And it doesn't matter what is your computer, as long as you understand how to work with Git. Believe me, this is what happens in industry in so many different levels. It's not only coding. Git is now working with even uh, computer images. So instead of uh, pushing and pulling uh, code, they create small computer images, and if they want a new computer, they simply clone the computer and then push it upstream into cloud. So suddenly you have a computer. As easy as that. If they want to make any changes, they simply make some changes to the computer that they created over here, and then push the changes up to the rest. It happens in many different levels, and you will see it hopefully in future. Are we okay with this? We understanding what is the purpose of workshop 0? Everybody's okay with that? Give me a thumb up if everybody's okay. I want to see people giving me thumbs up. Okay. Uh, Gomez, I don't know how to pronounce your first name. Can you help me pronounce your first name? Is how? How do you say that?
Are you listening?
Yes, I am listening.
Okay, I just don't know. Sometimes it bugs, so I need to ask.
So how do you?
It's just João.
Jean?
João.
Joao. Okay, Joao. Go ahead. Thank you very much, Joao. Okay. Now.
It can be just Gomes or João.
Okay. Okay. I have a friend called Gomez, so it's easy for me to.
Yeah. Okay.
Okay. So yeah. So
I have a question
go
just
ahead,
in
please.
regards to the workshop. I'm not sure if we talk about this and I just happened to miss it, but because we are not at Seneca today,
Hmm.
I assume we don't need to deliver anything as part of workshop 0, right? Just
If you check
go
the
to.
due dates for if you check the due date for workshop, you see it's due next week, not now.
Oh, okay, okay.
So let me show you to one more time. So as soon as you get connected to Matrix, you have access to Matrix. Let me clear the images over here. So as you see, it says 16th. You see, submissions are opened on 16th, and today is 9th. So it's 7 days from now.
Okay.
Got it?
All right.
All
Uh-huh.
right. And of course, when you're coming to the lab next week, I'm going to help you guys to go through the submissions and everything. So, but try to finish everything and come to the workshop either only for your submission or uh, to get help for problematic stuff. And if you have any problem with this with setting of your computer, book a private email put a book a private meeting with me, then make sure you get to the online meeting using Microsoft app, not Microsoft Teams web. It must be Microsoft Teams app, so I can take over your computer and help you with your setup. And if you have a Mac computer, make sure that you try sharing your screen and giving permission to use your Mac with a friend, because Mac has crazy settings with security. You have to make sure that you apply all those things. Otherwise, it doesn't allow you to do that. Any questions? For the labs, do we
It's
have to
fine.
submit? Give me a second. Ed wrote something. For the labs, do we have to submit them on campus, or can we submit them over? You are never allowed to anything submit from home unless it is out of date. So on-time submissions that receives 100% must be done from the lab computer at school. If you are late, you can submit it from home, but you only get 60%. And that's including the reflection and everything. If you don't do a proper reflection, even the 60% will go less than that. You can complete everything at home as you mentioned, and then come and submit it as at school. How do you do that? You use dash feedback. With dash feedback, you will uh, check your workshops to make sure everything is good. Then you can come and set it up at home. Where can we find the recordings for the lectures? There is no guarantee that there is any recording for the lecture because you're OOP244 and this is an in-person one. But if you click on the meetings that I record the stuff in that meeting, there is a tab called recap. If you click on recap, the transcript, videos, everything that is recorded about the uh, meeting will actually get added to this, will actually be posted over there. So that's how it's done. Just be aware of that. So, any other question? Again, you do not need to remember. I see that Ed says I can't remember all the submission steps with this recording be uploaded. The recording is not uploaded in Teams. Teams automatically shows the recording as soon as the meeting is over because I am recording right now. And because it's being recorded, as soon as the meeting is over, you'll see the recording in there. Number two, you do not need to remember anything. The instructions for the workshop, they are all in the workshop, and you don't need anything that I said in class to help you to go through the workshop. The instructions of the workshop are complete and to the detail to tell you exactly what you need to do for the workshop. Okay? For the submission on putty and everything. Again, everything is in here. It tells you exactly how to do it. Lab submission. For full mark, you should do this. Run this, replace this with that. It tells you exactly what the submissions are. Everything is there with videos that helps you to go through everything. Anyways, and if there is any problem, uh, either book an appointment with me or come to the lab. Any other question? Any questions?
No, all good.
Fantastic. Give me a thumb up if no, you don't have any questions. All right. Good. Okay. All right. So now that we are okay, let's talk about modular programming. Actually, what's the time now? It's 12:22. We could actually, it's just 35 minutes. That's okay. So I'm going to go through modular programming and explain how modular programming is and what are the things that we need to know about it. Again, I'm going to go through the notes that we have over here. So modular programming, object terminology, we went through it. So I'm just going to quickly go through what we've talked about last time, and then I'm going to talk about modular programming, and we're going to be done for today's lab and lecture. At any moment, if you have any question, if you see I am talking, do not wait for me to uh, do not wait for me to stop talking. You just activate your microphone and ask a question. Okay? All right. So we talked about object orientation. We said we have three different things in object orientation. We call them, let me just see the things we have. We talked about all these. We did not talk about namespaces yet. I'm going to talk about it soon. I just want to see what is here. All right. Now, again, remember, it's your responsibility. I'm not going to cover everything that you see in here. You need to actually go through this and understand, read it and understand how everything is, and you come with questions with in the next lecture. So on Monday at 2:25, when you are coming to class, you should come with questions about these three topics that we are supposed to cover today. Okay? We talked about object terminology. We said exactly what an object is, bringing data and behavior together. So essentially, when we say object orientation, we try to put the data and behavior together inside what we call a class, and therefore each class of ours is capable of performing action on its own data, and it resembles an object. Now, there are three specific pillars of object orientation that we need to understand. Number one, I always mention number one, is encapsulation. So encapsulation is essentially, as I mentioned, putting the data and behavior together. So data and logic go together inside your class, and that class knows how to deal with its own data. As I mentioned, if you ask for someone's age, if I told you how old are you, you're going to mention to me what is your age, because each object has its own attribute. If you ask me how old I am, I'm going to tell you I'm 59, and that means I am 59 years old because that's my attribute. If you tell me what do you teach? Then I'm going to say I'm going to teach C++ OOP244. If you ask another professor what do they teach, they know what they teach and they can answer you. This is called encapsulation, putting the data and behavior together. A side effect of encapsulation is essentially information hiding, which means you do not know what I teach. If I told you I'm a professor, by looking at my face, you don't know what I'm teaching. You have to ask me. You cannot somehow secretly find out what I'm doing. You have to ask Fardad, what do you teach? And I'm going to say, I teach core programming subjects, etc. So then you're going to get an idea. Information hiding is one of the most important aspects of encapsulation, which each object keeps an information private and only exposes what is needed by others. It's not going to just give everything to everyone. Are we okay with this? Give me a thumb up if we're good. All right. Good. Now, next thing we need to talk about is inheritance. Inheritance is reusing code in C++, in object orientation. What it does essentially is this. Instead of reusing code in C language when you work, you created a function and you kept calling it here or there. So you reused one function many times and you call that that's reusing code. I don't have to write the function anymore. In object orientation, it's a different ball game. In object orientation, you reuse design. So essentially, you have an object, and out of that object, you create a new object that has all the capabilities of the old object with more. A perfect example for it is this. Imagine if you are in a place that all people have over there are bicycles and cars. There is no motorcycle over there. Nobody knows what a motorcycle is. They just have bicycles and cars. If you want to explain to them what a motorcycle is, it is very simple. You can reuse design. What you can say is a motorcycle is a bicycle with an engine. So immediately they would know what a motorcycle is because they know what a bicycle is. When you say motorcycle, they know it has two wheels, they know how it steers, they know how it stops. But when you say it has an engine, immediately they say, oh, no more pedaling anymore. The engine will move it. And therefore, you reuse design. You had a class called bicycle, you inherited it into another object that you call it motorcycle. Therefore, motorcycle has an is a relationship. Extremely important. Extremely, extremely, extremely important. Is a relationship. That means inheritance. Is a relationship. That means inheritance. If somebody tells you has a relationship, that is part of encapsulation. It has nothing to do with inheritance. Why? Because has a relationship, it means attributes. It means car has wheels. Car has engine. You cannot say car is wheels. Car is an engine. You can say car is a vehicle. That we understand. That's inheritance. It means a vehicle is something that transports people and goods. So therefore, a car is a device that transports peoples and goods with more. So has a relationship is encapsulation. Essentially, it means when something has something, it's attributes. Human beings, they have eyes, they have head, they have hands, they have foot. That's what we do. Okay? Do we understand what inheritance is? Yes. Go ahead. Nazari, Shagufa. Was that you understood or you had a question? Ed, you said does it mean attribute? Oh, that was a mistake, no problem. Ed, you said does it mean attribute? Does inheritance mean Not at all. Zero. Not at all. I just explained to you is a is inheritance, has a means properties. Inheritance is never properties. I cannot say Ed is head. Ed has head. Ed doesn't is not head. You follow what I'm saying? When you say is a, if I say Ed uh, is a male human being, that is proper. If I'm sorry, I have that's how you say it. So that is inheritance. But if I say uh, Ed has a human being, that's wrong. It's not correct. Has a means properties. Is a means inheritance. Is that clear, Ed? Fantastic. Exactly. Pizza is food and pizza has pepperoni. It means its attributes are pepperoni and cheese. Pizza has cheese, but pizza is food. So attributes of pizza, a pepperoni pizza, is pepperoni, cheese, pizza sauce, and dough. These are the things that we say it has. But together it's food. It means it nourishes you, it gives you power, energy, and so on and so forth. That was perfect actually. All right, so that's that. And the next thing we need to talk about, ta, 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 ta. The next thing we need to talk about is polymorphism. The polymorphism is something that is extremely important to understand. Polymorphism talks about actions of a class, things that a class can do, or things that can be done in an object-oriented world. With polymorphism, an object or any action can be done in many different ways. So, unlike regular programs that we have written before, when you actually created an action, you could not recreate an action with the same name. If you wrote a function in C called print, that was it. You could not write another function called print. It was the one and only. But now, in an object-oriented world, you can write several functions with the exact same name, but they behave differently. For example, I can say airplanes fly, or I can say birds fly, or I can say Superman flies. These are all fly actions, but each one does the fly in a different way. And this is called polymorphism. By definition, polymorphism means doing the same action in different ways. And we are going to enforce that to see exactly how we can do it in C++. So remember, polymorphism means doing the same thing in different ways. Functions with the same name can accept different arguments and work differently based on who they belong to. Do we understand what polymorphism is? I want thumbs up if you do. All right, how to implement it is something else. Gomez, are we good? Chris, Ed, Nikita, we're all good? All right, fantastic. Okay, so that's that. And now modular programming. How do we do modular programming? So what I'm going to do now, again, because I am working on a repository, the very first thing that I'm going to do, I'm going to go to 2254. Oh, not here. I'm going to go to OOP244NAA nodes because it's in this repository. Where is it? Let me show you. Because it's here. Seneca OOP244 var.naa notes. You see that? I have cloned this already on my computer in here. So what I need to do is to first pull because I want to start working on it. See, I am exactly demonstrating how you are working on your workshop. So I'm going to right click over here, sync, and I'm going to leave this open while I'm working in here. So I'm going to say pull. Always pull before you do anything. And we're done. So pull is done. I'm good. I didn't get any error message. Everything seems nice and dandy and good. And it says success. You see that? So it says success. I pulled it. Everything's good. Now I can actually start working. I start Visual Studio. Not this one. I'm going to start a new one. Create a new project. Empty project C++ Windows console. Yes, perfect, Ed. Always pull before you start adding anything new. When you want to work on a repository, your master thing should always be to pull. Pulling makes sure that your repository is updated with the latest changes of upstream, and therefore it's safe to start working. Now I'm going to say empty project. I'm going to go next. I'm going to select the repository that I have as the place that I want to create my work in it. I'm going to go into notes, and today is May 9th. So I'm going to select this point, select this one, and I'm going to call it B May 9th. So in your case, it could be workshop 1, workshop 10, and you create it in your workshop repository, where in workshop directory in your repository. So I'm going to click on create. And then in here, I'm going to add a new file, prg.cpp, and I'm going to start typing over there include iostream using namespace std int main return 0, and then in here I'm going to say cout OOP244NAA May 9th. Compile and run, make sure everything is good. It compiled, it ran, everything got executed properly. What I will do is this, I'm going to say commit and select all. Then I'm going to say started the modular programming lecture. I'm going to commit and push. Commit and push in Tortoise Git is push all script that I asked you to create in your workshop 1. So I'm going to say commit and push, and all gone. Now everything that I have done is on the repository at this stage. So essentially, if you go to the repository, you will see over here in notes, I have started modular programming, and it's May 6th, and everything is right up there. Are we okay down to this point? When I ask that, please give me thumb up. I don't have to tell you thumb up. So when I ask everything good, give me a thumb up. Let me see what said before. Oh yeah, before we even start the lab. That's right. That's exactly the point. Before you start anything, first you pull to make sure you have the latest changes on your computer, and then you start. Okay, now let's see what is modular programming. Modular programming tells you how to create modules for different things. So let's say I want to create a program that receives numbers between certain values. Okay, so number receiving thing. What I can do over here is to write a function just to do that. I can say over here int get num, and in this get number of mine, I can actually get a number. So what I can do in here is writing something like, what do I write? So I'm going to write something right cin. So I'm going to create an integer number, and I'm going to say cin. Cin is console input. It's an object that extracts information from the keyboard. Okay, and doing so, what you need to do over here is simply tell where you want to put it. Unlike C language, the extraction operator that extracts information from console input, it's a polymorphic thing. So you don't need to mention how. If you say put it in an integer, then it will try to read an integer. That's what it is. And then what I'm going to do over here, I'm going to say return number. Do you remember flushing keyboard? Did you do flushing keyboard in IPC 144? Give me a thumb up if you did, or answer me. I just want to know if you have done stuff like that. No, you did not do that. Okay, so you did not do that. So for now, we're not going to talk about it. This is what I'm going to talk about. But for now, this is what it is. So I'm going to say cin number. I'm just going to read information from the number and return it. So now in here, I can simply say something like cout how old are you? And I'm going to go to new line and show a prompt. And in here, I'm going to create integer age. And now I can say age is equal to get num. As easy as that. Okay? And then after doing this, I can say cout, you are age years old. And then I go to new line. Okay? So doing something like this, what happens is that yeah, I'm going to run the program and you'll see. So first I'm going to run the program. How old are you? Oh, I see, I made a mistake. The prompt is supposed to stand over here. It's coming to the new line. So I made a mistake. I'm going to come over here. I shouldn't have go to new line over here. So this is going to be the end. Now one more time. How old are you? Now it's better. Now I'm going to write over here 59 and I'm going to hit enter. And as you see, it says you're 59 years old. Are we all okay with the code that I've written? All right. Thumb up is easier. Okay. Now I want to write another one that actually tells me between which ages, like which number between which values are valid. For that, I'm going to create a different one. Yes, of course, with an if statement, but I need to design something. In C++, we have a new type. That type is called Boolean. It only accepts true or false. So we didn't have this one in C language. In C language, you had to return an integer being 0 or 1, it would be true or false. But in here, when I return a Boolean, then the value will be true or false. So I'm going to create another one. I'm going to say get validated number. Now in here, I'm going to receive an integer pointer. That is the number. Now I'm going to have integer minimum and integer maximum. So now I created the second thing in here. Now what I need to do is to receive an integer. So I'm going to have integer number. Now I'm going to say cin number. Now I'm going to check if the number is greater than or equal to minimum and number is less than or equal to maximum, then we are all good. So I'm going to create over here a Boolean and I'm going to call it result. And I'm going to make the result by default false. So as you see, we have false or true in C++. So you can actually set it to false. So I'm going to say if number is greater than minimum and number is greater than maximum, then everything is good. Because so the target of number now will be equal to the number I read. And I'm going to say result is true. And then at the end, I'm going to say return result. So this function of mine works like this. Now I'm going to actually walk through it. So instead of get num, oh, I made a mistake. I shouldn't have done that. I should have done this. Reuse my code. Is equal to get num. Why am I writing it again? That's wrong. This is better. Do we understand what did I do wrong? One person understands, two people, yeah. Reuse your code. You should not redo the code that you have done before. So because getNum is like that, I'm supposed to do it this way. So in future, if I improve my getNum, all the functions using getNum will do the same. Anyways, so instead of getNum equal to age, I'm going to do like this. I'm going to write the program like this. I'm going to say Oh, actually, it's a good idea to do something else. Give me a second to show you what I've done. So I'm going to remove this for now. I'm going to save this. Take a look what I'm doing right now. I'm going to save this. I'm going to say Alt. I'm going to save this. And now I'm going to come to the uh, program, to Git. In here, I'm going to say commit. And I'm going to say over here, uh, completed get num function. I'm going to commit and push. Now I'm going to go back to my programming again. Now I'm going to add validated numbers. So let's actually do that. So in here, instead of having get num, I am going to write something like this. I'm going to say if get validated number, and I'm going to put address of age, and I'm going to say, let's say it's, you should be between 18 and 100 years old or 90 years old to use this program. So if this is a validated number, then I'm going to say you are hello and welcome. Welcome, you are age, years old, and permitted to enter. Something like that. Okay? And in here for else, I'm going to say cout invalid age entry. So now my program is more comprehensive. So if I run the program now, how old are you? I'm going to say 12. It's going to say invalid age entry. I run the program. How old are you? I'm going to put 100, invalid age entry. One more time. In here, I'm going to say 50. Hello and welcome. You're 50 years old and permitted to enter. So now the number is written that way. Let's walk through this and see how it works. I'm going to press F10. If you go to debug, it shows you exactly what it is. Same thing in Xcode. Go to Xcode and see which code does this. I know Xcode does it too. Which key does it? You can do the same way. So I'm going to press F10. When you say press F10, it means step over, but essentially it means start running. Because I'm saying start running, then it's going to compile and stop at the very first thing. So I'm pressing F10. As you see, it runs and puts the arrow at the beginning of main. I'm going to put this one at left and put the output at right and walk through it. So I'll press F10 again. F10 means step over, so it actually jumps over it. Now I'm going to bring the mouse over age. As you see, I have some garbage number in it, which is absolutely nonsense. So I'm going to continue. Now it's going to say cout OOP244 May 9th. Now it's going to say, how old are you? Now, if I press F10, it's going to run the if statement as one statement and jump and go inside. I don't want to. I want to go see how it works inside. So I press F11 because F11 means step into. So F11 will actually go to the function. And now when I'm here, I'll see in here, it has the address of the garbage, which is age. It has 18 for min and 90 for max. And Boolean is garbage for now. We're going to go through pass through and now becomes false. Good. Now it's going to run get num. I know get num works. I don't want to walk through it. I'm going to press F10. When I press F10, it jumps over it, which means it runs it as one command. It's not going to actually go inside num. As you see, it's now waiting for me to enter the value. Now I'm going to put over here 45 and I hit enter. When I hit enter, It checks to see if number is greater than 45. If I want to know what is the condition, highlight the whole thing, bring the mouse, you see it says number greater than min is true. And in here, I have number less than max is true. Now you can highlight the whole thing. I'll see that that condition is true. You can actually see what the number is, 45, minimum is 18. This number is 45, minimum is max. And now because it's true, it gets in. Now I'm saying target of num, I can highlight the whole thing, becomes the garbage will be set to 45. Therefore, target of num will be 45. Result that was false becomes true. And when it comes over here, as soon as I click over here, as soon as I press F10, the result that is true will be coming back in the if statement. Now you can actually come back over here and click on autos. If you click on autos, it always explains what are the values over here. And as you see over here, it says get validated number return true. So it actually tells you the function that just was called, what did it do? And we say it returned the age, which returned the condition that was true. Therefore, it's going to print the whole thing, come to the end, and main will return 0, and we are all set and done. So the program is working properly. Are we okay with what I just talked about? I want to see thumbs up if we are okay, or questions if there is any question. Is getNum for user input in this case? Yes, it is. Any other question? We're good? All right, so now that we have accomplished this, what I'm going to do over here, I'm going to actually commit it again. So now in here, I'm going to say commit, and I'm going to say get validated num completed, commit and push, and we'll go there. Now, if I go on GitHub, this is what you see. If I refresh, oh, not here. If I refresh right now, you will see that it says get validated num completed. If you click over here, you will see the difference before and after. You see that? You can actually do like this. It shows everything. So get num remains the same. This was added. This is how main was and is. So everything that was changed actually shows to you, so you know what was changed. This gives you help for every stage of the work, and you can do that with TortoiseGit too. So with TortoiseGit, you can come over your repository, right click. You have to always put comments, because otherwise, how do you know what did you commit? Every commit must have a comment, otherwise, oh, put comments in the code, you mean, Ed? I'll explain how. Give me a second. Okay, so now I can go toward this Git and I say show log. And as you see, show log shows exactly what's going on in here. You see this? This completed this function, and for every and each it shows what was modified. So if I come to get num completed and double click over here, it shows what it was, and it was, see that the main was completely empty. I added get num. If you come back to this stage, it actually tells you what was then. So now it was get validated number. So you can see all stages of development of your application, and it's extremely helpful. Now that we have done this, let's actually make this thing proper. First of all, you never write functions at the top of main. That's not good. So I'm going to bring the functions down. And you change these things to prototypes. So now I have the prototypes at the top and the functions at the bottom. Are we okay with this? All right, now I'm going to run the program again. And now what happens? Everything's working. Good. I'll get out. Again, you know me. I have to commit and tell you what did I do. Actually, I never create the functions at the top. It's always better to be at the bottom. But at the end of this lecture, you will see that this is not how we develop. In reality, you will see what happens at the end. Give me some time, Ed. Okay, so now that this is done, I have the prototypes at the top. So I'm going to say, where was I? Oh, I closed it. Darn. Let me open it again. Folder. There we go. So I'll come back over here. I'm going to open up the sync again. I shouldn't have closed it. There we go. So in here, I'm going to say commit. I'm going to say step 1 for modules. Create modules, that is functions with prototypes. Commit and push. And again, when the log comes and you take a look, you will see what happened. Anyways, so after you do this, then we're going to start dealing with modules. What is a module? A module is essentially putting all the relative actions, classes, code that is for one purpose into a file of its own. So this number entry stuff that we are doing is essentially to enter numbers, right? So if I want to name what these actions do, is actually number IO. num.io I'm going to call it. So number.io is what I'm doing in here. So for that, what you do, you are going to create 2 files for each module. One file is called the header file and the other one is called a CPP file. So I'm going to right click over here and I'm going to say add new item CPP file. I'm going to call it num.io.cpp. That's the name of my module. And I'm going to create another one over there, add new item num.io.header file. So 2 files I create, one CPP, one header file. Then I move all the prototypes to the header file. And I move all the functions inside the CPP file. Then I will see what includes are needed over here. I have cin, so I need to include IOStream and using namespace. And std. So now the functions are here. The header files, they don't need anything. They don't need any includes of any kind, so I'm just going to leave it. Remember, it is extremely important. Only include if needed. Don't do just in case includes. That's very bad programming. Now I'm going to come back to prg.main. Now that everything is done over here, all I need to do is to say include num.io.h. Because this includes those 2 prototypes. Now, because then the function will be known to main. And also because the compiler knows where the body. What's PRG for? What do you mean by PRG? Yeah, PRG is where the main file is, a program. It's the main, yeah, it's a file, yeah. So now if I compile this code, it will run the exact same way. Why? Because all the source code is available to the compiler. All the header files are available to the compiler. Everything is available to the compiler. So I have no problem over here. Now, let's take a look at matrix and see how it's going to look on matrix if I want to do this. So first of all, I'm going to commit and I'm going to say step OOP244 modules. Put prototypes in headers, header, put functions in CPP. Commit and push. Now I'm going to go on matrix. I'm going to go on matrix. Okay. This is not my OOP. This is Fardat. So I'm going to go over there and I'm going to take Fardat's thing out. So in here I'm going to say cd yada yada. I'm going to go back. Okay, I am in demo. Now in here I'm going to clone the repository that I have. You shouldn't do yeah, I mean actually I'll explain it. So I'm going to come over here in OOP244 organization, and I'm going to copy this. Now I'm going to clone this on matrix. So I'm going to say git clone, and I'm going to clone the nodes. Now that I have the nodes over here, cd fardat's nodes, I'm going to go to nodes. I'm going to go to B May. I have my PRG CPP and everything in here. So how do I compile it over here? This is how it's done. You write G++, then you only put the CPP file names, numio.cpp, prg.cpp. Let me actually clear it so it becomes more visible. So you write G++, numio.cpp, and prg.cpp, and you put -o. I'm going to call -o is the output name. If you don't put anything, it's going to call it 8.out. So I'm going to say my PRG, okay? And you hit enter. So it compiles the code, and if you look at the code over here, you have myprg. If I type over here myprg, it runs. It says, how old are you? I'm going to say 20. And it's going to say, hello, you're welcome. You're 20 years old and permitted to enter. So as you see now, I did the same thing on matrix without any FTP of any kind. I just pulled the values in here. I'm going to leave this window as is, and I'm going to go back over here and continue my work. Are we okay down to this point? All right. So let's go back to here and continue. Now, the next thing we need to do is to prevent the compiler to, by mistake, include something twice. Ed, you keep mentioning comments. What are you talking about when you say comments? Comments in code, you mean? To add comments at what the function? Of course there is. This is how it's done. Give me a second. This is how it's done. So you go to the, oh yeah, give me a second. Take a look. This is how it's done. So you come over here, right before the prototype, and you type 3 slashes, 1, 2, and 3. Why did it do it like this? It went bananas. Control C. Then I don't know why it did it like this. It's supposed to do it properly. Let me see. 1, 2, and 3. Yeah, there you go. Because it was the last line. So when you do 1, 2, 3, it gives you a comment like this. Summary, I'm going to say over here, gets validated integer, and integer. Gets validated integer. Num, I'm going to say pointer to the number, to value read, to the value read, to read to the value read. In here I'm going to say minimum acceptable minimum acceptable value, and for max I'm going to say maximum acceptable value. returns true if valid, false if invalid. Okay, after doing all this, and for get num, I'm just gonna put 1, 2, 3. I'm gonna say gets a number, a, a number from console. Console. And for returns, I'm gonna say returns red number. I save it. Now, if you go to your program, you bring your mouse and hover, it actually gives you that help. So it's going to say gets validated integer, parameters, number pointed to the value read, minimum, maximum, and so on and so forth. Does that? 3 slashes, three, not 4, not 2. You put 3 slashes, automatically it creates the XML document for you. If you put 2 slashes, then it's manual. You have to manually enter it. When you put 3 slashes, this is standard in all advanced IDEs. It creates an XML document for the code. Are we good with this, people? All right. Now, there is a problem in here. Sometimes by mistake, a header file is included twice without knowing. Why? I'm going to explain later. But sometimes you have stuff like this. If you include something more than once, then the compiler is going to tell you there is problem because the code you had over there has multiple definitions. To fix this definition, this is the rule we follow in OOP244. You write this expression and you have to memorize this. It is not how you do it with C++, Ed. The 2 slashes that you see over there, it is for Visual Studio. In C++, you have 2 slashes, or like C slash and star. That's standard commenting. The 3 slashes, it is XML documentation, and Xcode does it, and Visual Studio does it, and all the good stuff. Other than that, you can just comment it normally like regular C. Anyways, so to prevent this, you are writing something that communicates with the compiler. And this is how it's done. You put a hashtag, you say if NDF. This means if not defined. Then you write the name of the college, the company that you're in, the namespace that you're writing it. We're going to write over here Seneca. You have to memorize this. There is no syntax error in it. It's a standard we are going to follow. Then you put an underline, you put the name of all header file, all capital, num.io, then underline H. Then you copy this and paste that at the bottom, and you change the second line to define. You put all your code inside here. Header file between these 2 lines. This is called compilation safeguards. So what happens by doing this, you are telling to the compiler, if this token is not defined, define it and continue compilation. The compiler, the first time that is being included, actually reads that and will define a dummy value which is tied to the name of the function, name of the header file. The second time it's included, because it is already included, the whole compilation will be ignored and compiler will not compile it. You do not need to understand it, memorize it. The pattern for it is this. If not define, namespace, namespace, header name underline H. Then you write define, and if the contents of the header file goes here. So anything that you write, now I'm going to explain what the header, what a namespace is, but just bear with me. Just know that Seneca is the name of our namespace, and I'll explain what it is. What about pragma once? Pragma once is too rich for your blood. It's OOP345. We are OOP244. We don't do pragma once. I do not want to see it there. You are not supposed to use it. You use this one. This is the manual way of doing it, and it works everywhere. Okay? And that's that. So after doing this, everything is set and done, and this is a must. You have to do it. So we are one more step in our module creations. So again, I'm going to go here and I'm going to say commit step 3 for modules, creating compilation safeguards for header files. Commit and push. All right. Are we okay down to this point? Anybody have any question that you want to ask? If you have a question, let me know. All right. Now the next thing you need to do over here is to understand what is a namespace. So namespace is again something that we have to explain. It becomes a little tricky, but we have to explain. So let's say you are working for a company, okay? And in that company there are different departments. Let's say I want to write, and for that I'm going to actually create another thing over here just to explain to you what it is. I'm going to create a new file, add new item, txt. So let's say you are working for a company, and in that company there are two departments. One is called EDU for education, and the other one is HR, that is for human resources. Now imagine that, let's say at Seneca we are doing this. Now let's say this is the file that the HR is working, HR file to create a student, structure. Okay, structure. If that's the case, they want to create a student, so they create a student header file, right? So let's say they create us, let's say the file name is student header file. Okay, so I'm going to call it hr.h, HR header file. They create the safeguards and everything, and in here I create struct student, and as an HR I need to know how much OSAP as HR I need to know how much salary the student is getting, because HR is human resources to hire students. And then I have over here an integer for student ID, and I have character for student name. So this is my student structure. And now the education part, they are creating a student structure too. The file name for it is edu.h, and they create struct student. But for an education point of view, I need to know what semester the student is in. I need to know what is its ID. I need to know what is the GPA, and I need to know the name. So when you look at the two structures over here, you will see that if I include these two inside the program, so main system is here, and in main system I have int whatever. In here I'm going to say include hr.h and include edu.h. What is going to happen? It's going to be two structures for the student with the same name, with different definition. So the compiler is going to give you an error. You cannot create two structures with the same name. Therefore, when we have stuff like this happening, what we create is namespaces. So I'm going to tell to the HR department, hey, HR department, you are allowed to create all your codes in a namespace called HR. So what happens, the HR will write namespace HR and then creates the student in there. And then I'm going to say for education to create it in edu namespace. Now doing so, doing something like this, a namespace prevents conflict. So when I include this, if I want to create an HR student, I'm going to say HR student, HRST. And if I want to create an education student, I'm going to say EDU student, EDU. ST. So I have two different ones and there is no conflict between the names. So namespaces essentially reduce conflict. Do we understand this? 1% said yes. Okay, the rest, if you don't understand it, doesn't matter. Come the next day to the class and I'm going to explain. So Shagufo, let's literally put it a proper name. It's two different namespaces. It's a space for names. So the names remain unique. In one namespace, I cannot create two different things. The difference between a namespace and a class is that I can create another namespace, call it HR, and in that namespace, I can create whatever I want, like void calculate salary. Something like this. I can create a function whatever I want. Two namespaces with the same name, they merge. There is no conflict. Essentially, it means the student and calculate salary, they are both in the same namespace. There's no problem. But when the two namespaces are different, they prevent collisions. So you can have several namespaces with several different namespaces. And when they created C++, they got all the standard stuff, they put it in a standard namespace. That's why we always say using namespace std. In our example, if this whatever was intended to work for education only, instead of keep writing edu as scope resolution, I could simply write over here using namespace edu. And then I did not need to do this. So if I don't mention what type of student, it will be the one that I'm using. And when I don't mention it, I have to qualify and say what it is. So this student will be an edu student by default because of using namespace edu. So because of this, we're going to practice this in all our applications. Anybody have any questions? Because of this, we are going to practice this in all our code. So as a Seneca student, we ask you all to write everything you do in a Seneca namespace. So you have to contain all your code in namespace Seneca. And that's why in our safeguards, we always started with Seneca. If this namespace was BMW, you had to write BMW. If the namespace was EDU, you write EDU over here. We do namespace, and now I'm going to come in num.io. In here, I'm going to write namespace Seneca. And done. So now in my main, I not only say using namespace std, first of all, namespaces are down, but also I'm going to say using namespace Seneca. And the program will work perfectly because this is in namespace Seneca, and therefore it's going to be used and working accordingly. And that is namespaces. Are we okay? Yes, Leo. Oh, that was a thumb up? Okay. All right. Okay, good. So you don't have to be perfectly good with this. Please revisit the thing. Go study namespaces, these 3 pages. So we are using both of them. Oh yes, you can use 50 different namespaces. It doesn't matter. But there is one rule that you have to always remember that we're gonna mention. I'm gonna mention the next day that we are coming in. That is, you are never allowed to use a namespace in a header file. You can implement it. Implementing namespace is perfect, but you are not allowed to say using namespace std. You should never do that. I'll explain later on. This is not allowed. Remember that. I'll explain why later. But anyways, that's it. Now I'm going to actually come over here and I'm going to say commit, and I'm going to click on all, and I'm going to say final step for modules. Put all your code inside the namespace you were instructed to. So depending on what are you doing in our system, in our study at OOP244, all our things goes to the Seneca namespace because we are Seneca students. But when you are working to at some place, then they're going to tell you which namespace you are going to create everything in. And that's that. Any questions? Suggestions? Objections? All right. So everything is done and we know what namespaces are. Your task for the next day is that you're coming in to come asking questions for the workshop and going through these 3 introductory pages. Welcome to Object Oriented, object terminology, and modular programming. Go through all these three things and you come with question the next day. If there's no question, I'm going to end the meeting. And when the meeting is ended, automatically the recording is going to be inside that meeting. If you open it up, you can see the recap and all the good stuff that you have. And I also will put the path for the codes in the meeting too, so we have it. Are we all good? All right. Thank you very much. Have a great day. Thank you very much for coming. And I hope the other people, other 10 people that were supposed to be in class, will listen to the recording too. Have a good one. Bye, everyone.